Okay, here we go. We're going to evaluate some functions and we're going to talk about intercepts. All right, so this is getting us ready for the test. So make sure you understand every single one of these problems. So determine if negative 3, 7 is a solution of the equation y equals 4x minus 1. Show your work. So basically it's asking us to remember some basics. And the basics are this. When I see the point negative 3, 7, I remind myself that the negative 3 stands for the x value and the 7 stands for the y value. And so when I go ahead and see the equation y equals 4x minus 1, it's asking me to do this. It's saying, oh, how many good colors can I get? Do I like this green? Or how about an orange? All right. I mean, I already had orange. Silly. It shouldn't take this long to pick a color, should it? All right, let's do green. So it's asking me this. It's saying when we see the x, instead of writing x again, let's plug the negative 3 in. And when we see the y, instead of writing y again, let's plug the 7 in. All right, so why are we doing this? Because if negative 3, 7 actually is part of this line, a part of this equation, then this statement's going to be true. And so what we'll do is this. We're going to put a 7 in instead of the y. We're going to bring down the equals. We're going to bring down the 4. Instead of writing x, we're going to write negative 3 and then the minus 1. And so what we're going to do is we're going to pick up our calculator and we're going to put this part in exactly as we see it, right? And so when you do that, we're going to end up, we still have the 7, we still have the equal. We're going to end up with what? Negative 12 minus 1. You should end up with a negative 13. And we're like, what? 7 equals negative 13? All right, is that true? Does 7 equal negative 13? No, it doesn't equal. So that means that no, this point does not work. A point that would work would give us something that's true. For instance, this is not part of your problem. So if you're just mindlessly writing things down, you're going to be like, what is she doing now? All right, this is a separate part of the problem. I'm just showing you what would happen if something really did work. All right, so let's say we have the same thing, y equals 4x minus 1, and the point, let's give it 2, 7. Okay, this one's going to work. When I plug a 2 in for the x and a 7 in for the y, watch what happens. 7 equals 4 times 2 minus 1. When I put this in, I get a 7. 7 equals 7. So therefore, 2, 7 is a part of this equation. It's a solution of this equation. And if we graph this, we would get 2, 7. The point 2, 7 would be on that line. All right, so once again, that was a separate problem, not on your notes. All right, this says determine if negative 4, negative 1 is a solution of the function. All we have to do is plot that. So negative 4, we start at the origin. Negative 4 tells us to go all the way to negative 4. So I'm gonna show you where I'm going. So I'm starting at 0. I'm going all the way to negative 4, and then I'm going down negative 1. Now, what you just saw, I'm going to undo. Okay, we are still going to end up with the point there, negative 4, but don't be leaving the rest of it. Oh, can you even see that? All right, so is this point on this line? Absolutely. So yes, so that probably just want to plot and make sure it is. Oh, I'm stepping on my cord. Make sure it's on the line. All right, we've done this in Delta Math. This is just simply, hopefully you can't hear the beep, beep, beeps of the workers outside or below me. I'm not sure where they are. So f of 5 just means what is the value of the function when x equals 5. All right, so let's find out. That just means take 5 and plug it in. So you could plug it into all the x's, okay? Because that could actually make a lot of sense. So we're going to go ahead and we're going to plug it in here. So f of 5, we've talked about that already, what that means. And then we're going to see another x, so we'll plug in a 5, and then we'll have a plus 10. So all we're going to do is pick up our calculator, And so f of 5, which is the value of the function when x equals 5, equals whatever this is in our calculator. So have you picked up your calculator yet while I'm talking? Let's see. You should get an 8, right? So that is our answer, 8. All right, find the value of f of 4. So f of 4 is just meaning where is y when x equals 4? Or where is the graph? Okay, how tall is the graph? How low is the graph? How high is the graph? Where is the graph when x equals 4? So we're going to be a little person on 4, and we're going to look up at the graph, and we're like, oh, there you are. How tall are you? You are 3 tall. So f of 4 is 3. And I think, oh yeah, we've been doing these with Delta Math, right? I'm making this this video in the summer, and so I've kind of made the whole year, and I can't remember where I'm at. But I'm pretty sure you all have been practicing this, and you don't need that. Find the x and y intercepts of the function. All we need to remember is this is my y-axis, this is my x-axis, right? And so for the x-axis, we look to see where this line crosses through, and it's right here at -2. All right, so I could just put -2, but it wants me to write it as a coordinate point. And so think about it. When we graph this, we go over to -2, and we don't go up and we don't go down. So we put a 0 there because we just stay still. There's no moving up or down. All right, so the y-intercept, we look for where does the graph cross the y-axis, and right there. And once again, the number goes first. It's what we do with the x. Do we go left or right? We didn't. We didn't move at all. So it's a 0. And then when we went up 1. So it's really interesting. The y-intercept has the number in the y part of the point and a 0 in the x part. And the x-intercept has the number in the x part of the point and the y part 0. All right. Let's see. Do we have any more of these? Do we have, oh gosh. All right, 2 more. We can do it. We can do it. Find the x and y intercepts of the function. All right, so this is where we want to probably do the cover-up method. That makes the most sense. So if I wanted to know, let's say the x-intercept, all right? So x-intercept, I already know that I'm going to put a number here, and the y is equal to 0, all right? And so if the y is equal to 0, well, you know what? Let's just go ahead and plug in that 0. So we're going to have what? 4x minus 2 times 0 equals 20. And so when we are multiplying, when we look at this part right here, that -2 times 0, if we put that in our calculator, we're going to get 0. It is gone, 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 gone. We don't even see it anymore. All right? So that's why we do the cover-up method. I'm pretty sure, once again, I don't know where we're at in the year since I'm filming in the summer, but we just will have 4x equals 20, and then we're just going to solve a one-step equation, x equals 5, so we put our number there. All right, we're going to repeat the same thing, but this time we're going to do it for the y-intercept. And so the y-intercept, we remember from last time, pink. So the y-intercept, the number goes in the y spot and the x is 0. So let's go ahead and make that happen. Let's actually put the 0 in for x. So we'll have 4 times 0 minus 2y equals 20. And so guess what? 4 times 0 is 0. It goes away. That's why we're allowed to just cover it up because it's equal to 0. It's gone. So what do I have left? We have the -2y. So we're going to divide both sides by -2. And we're going to pick up our calculator and get -10. All right. So I think this is a review. Once again, I'm not sure where it falls in our year, but tell me, Miss Everly, quit saying that. All right. Find the x and the y intercepts. This one's easy. So wherever we see a 0 in the table, like right here is a 0 in the table. All right. Who's the 0? The 0 is y. Well, we know that's going to be the x-intercept, right? Because we know the number goes where the x is, and the 0 goes where the y is. The other place that is a 0 is the 0, 10. The number 10 goes here, and the 0 goes here, and we're done. So for some reason, I mean, I get it. It's very conceptual, and it's asking us a lot of different ways. But this seems to be hard for students, and so let's just practice until it's easy. All right, thanks for joining me. I did do all of them right. Gosh darn it. Did I? Yes, I did. We can go. Maybe I just wanted to get to 10. 2 and 10.